Hey guys, good morning. This is officially our last lesson of this unit, so you can start eating the popcorn and ice cream and celebrate. So we'll talk about inverse trig functions in this last one, and these inverse trig functions have a lot of overarching applications in so many situations. So let's first learn what they are, and then maybe we'll talk about some of those applications. So if there's a function that did the opposite of what this function does, or did the inverse of what this function does, I hope you remember that the inverses flip the x and y values, right? So the inverse would flip, first of all, you remember the inverses flip the domain and range. The domain of this function is currently negative infinity to infinity, and the range of this function is currently 0, sorry, not 0, negative 1 to 1, right? The range is negative 1 to 1. So we know that the range of the inverse function will be the same as the domain, but I'm going to talk about that in a little bit. And the domain of the inverse function will be the same as the range of the original function. So the domain would have to be negative 1 to 1. And this is a very, very important thing that I'm going to continue talking about. So first of all, this function has a range of 1 to negative 1, right? That's the y values, the maximum and minimum y values are possible or existing on this function. So if I say that the range of its inverse is negative infinity to infinity, that doesn't match up with this, because in order for a function to be an inverse, it must pass the vertical line test, right? It must pass the vertical line test. So if I drew the inverse of this function, which would look something like, let me try to show you, would look something like this, sine inverse of x would look something like that, right? And it stops up here, at pi over 2 and down here at negative pi over 2, because I need to restrict the range, and this Desmos is doing it for me nicely already, because that's the nature of the function. Because I need to restrict the range such that I have a 1-to-1 function. This function, you see, is a 1-to-1. For a function to be an inverse of another function, it must be a 1-to-1 function. So what's happening is this function was just kind of flipped around, because the inverse does the opposite of what the original function does. So this is what the inverse does look like. This extension that you see going up here does not exist on the inverse function, because if it did, the inverse function would not be a 1-to-1 function. A 1-to-1 function, remember, it passes the vertical line test, and this function would not pass the vertical line test if those things existed. The other reasoning is, if you continue going upwards, right, let's say up here at pi, then that means you have x values, you have more than one x value that, oh sorry, you have, yeah, let's just stay at, it needs to be a 1-to-1 function. So one of the very important things is that the domain of an inverse sine function must be from negative 1 to 1, right? Negative 1 to 1, and the range is negative pi over 2 to pi over 2. This domain means that the values that you can put inside an inverse function, the values of x that you can put inside here and get a reasonable answer, have to be between negative 1 and 1. Because if you put negative 2 here, it won't give you an answer, because the inverse function is always asking you what angle, what value. So say you guys know sine 30 is equal to 0.5, right? So if I came around and asked you for the inverse sine of 0.5, if I asked you for the inverse sine of 0.5, I'm asking you technically what angle has a sine ratio of 0.5. That's what I'm asking you, right? So I'm using this to explain why you can't have a value bigger than 1 or bigger than negative 1. Let's say you're trying to find the inverse sine of, say, positive 2 or 1.5 or whatever, as long as it's bigger than 1. There is no angle, and I'm sure you can agree, there's no angle that has a ratio of 2. There's no angle whose sine ratio is 2. The maximum sine value will be 1 and the minimum will be negative 1. So this is going to be very important. When you're working out these inverse functions, the domain has to be negative 1 to 1. And the other important thing is the range of values you expect to get out of this inverse function have to be between 0 to 90 or 0 to negative 90, depending on what value you're working with. So you can't get something like 150 degrees from this, right? This is always going to give you an answer between 0 and 90 if it's positive, or 0 and negative 90 if it is negative. Okay, so let's move on. So why do we restrict the range? I've told you it has to be a one-to-one function, right? So it passes the vertical and horizontal line tests. So let's try some examples. The sine inverse of 1, you're asking yourself, which angle gives me a sine ratio of 1? And that angle is 90 degrees. You can actually also do this on your calculator. Oh, sorry, it says no calculator. Never mind. So this is simply asking you what angle gives you a sine ratio of 1, right? What angle has a sine of 1? That angle is 90 degrees. I hope you guys remember that. This is asking you what angle has a sine ratio of root 3 over 2, negative root 3 over 2. I know you know that negative root 3 over 2 is the angle 60 degrees, but since it's negative, this will also be negative. Yeah, so you can break this down like this, because if you're figuring out what x is, then you can say the sine of x will equal to root 3 over 2, and then you're trying to find that angle x, which is 60 degrees. Alright, evaluate the following. So again, you're asking yourself, what angle gives me a ratio of 1 out of 5, right? So you can just go to your calculator and type in sine inverse of 1 out of 5, sine inverse of 1 out of 5, or second function sine 1 out of 5, and see what you get. Make sure the calculator is in radians. So this goes back to, and it says things that appear obvious but are not necessarily true. It goes back to what we've been talking about, the domain. Remember, the domain is negative 1 to 1, and the range is negative pi over 2. Sorry, these are included. The range is negative pi over 2 to pi over 2, right? This lends itself back to that. So this tells me that if I have, because this is a composition of functions, and naturally they're supposed to be equal to x because they're inverses of each other, but that's only going to happen if the values of x that you put in this function here, right? If the values of x I put in this function here are angles that are between negative 90 degrees to 90 degrees, right? That's only when this will be a true statement, right? If the angle you're putting here is 150 degrees or 120 degrees, this is not a true statement. Those angles have to be less than 90 degrees. And then this second one is only going to be a true statement if the values that I'm putting inside here for this x are between negative 1 and 1, right? Because the inverse function has a domain of negative 1 and 1, and if I put in any value that's bigger than that, then this expression does not exist. So very strict conditions here. This is only true when I'm putting in values that are between 90 and negative 90, and this is only true when the x values are 1 or negative 1. So the x value here is an angle, right? And the x value here is just a figure, the figure between negative 1 and 1. So that's the difference here. So, and the answer that you're getting from this is an angle, whereas the answer that you're getting from this is just a normal number, normal number. Okay, so let's look at some examples. The sine of the sine inverse of pi over 8. So I need to ask myself first, I need to go back to this and ask the sine of the sine inverse of pi over 8, right? That's what it's saying. No, the sine inverse of sine pi over 8. The sine inverse of sine pi over 8. According to this condition, the angle I put inside here, in order for it to be equal to x, that angle has to be between negative 90 and positive 90. So go here and ask yourself, is this angle meeting that condition that it has to be between negative 90 and positive 90? The answer is yes. Since the answer is yes, then this whole expression is just equal to pi over 8. Right? Let me explain that. Oh no, you can just rewind the video. So on this one, I'm going to go back and look at the expression, the sine inverse of the sine of x, and that x value has to be between negative 90 and positive 90. So let me come here and see. The sine inverse of the sine of x, this x has to be between negative pi over 2 and pi over 2. Is that the case? The answer is no. This angle is not between this. This angle is bigger than 90 degrees, right? So I need to find its reference angle. Since this angle is bigger than 90 degrees, it's somewhere here, right? This is 5 pi over 8, and I know that this is pi. I know it's here because it's not yet 8 pi over 8, because 8 pi over 8 would be pi, and this would be 180 degrees. But It's 5 pi over 8, so it's up there. And what's missing to make pi? Well, I hope you can see that from if I subtract pi minus 5 pi over 8, pi is the same as 8 pi over 8, and minus 5 pi over 8, what I get is 3 pi over 8. So I know from my previous trigonometry that this angle 3 pi over 8 has the same ratios as this angle 5 pi over 8, because it's positive here and sine is positive here. So I'm going to express this expression as the sine inverse of the sine of 3 pi over 8. Now in this case it is possible to do, and now in this case it is equal to 3 pi over 8, right? Remember, look at what's inside the function here before you conclude that an inverse of itself is equal to the value, or the x value. Alright, so yeah, the difference, I think I've just explained this. Yeah, and like I said earlier, these are very important, so make sure you look at them before you start to work this out. Find the exact value of the composite functions. The sine of the sine inverse of 0.5. I know that whatever goes inside the sine inverse function has to be between -1 and 1, right? That's what goes inside the sine inverse function. So that's the first check you make. If this check is complete and it's valid, then you move on to find the values. So you're asking yourself, the sine of the sine inverse of 0.5 should just be 0.5 because it meets this condition. But if you're wondering, how it works out, let's go the long way and see. The sine of, I know the sine inverse of 0.5 is asking me which angle gives me a sine ratio of 0.5, and that angle is 30 degrees, right? Or pi over 6. And when I take the sine of 30 degrees, that sine is equal to 0.5. So you could have just gone from here to here, because you see that this condition has been met. Let's look at part B and test the condition again. Whatever goes inside a sine inverse function has to be -1 to 1, right? So is this value here between -1 to 1? The answer is no. Since the answer is no, then this expression here does not exist, right? Or is undefined, or is impossible, whichever ones you want to use. And again, if you want to go the long way, you can say, okay, this is sine, the sine inverse of 1.8. You're asking yourself, which angle gives me a sine ratio of 1.8? Well, that angle does not exist, because the maximum sine value is always a 1, and the minimum is a -1, because the graph goes up and down like that. So it's not possible to have a sine value, an angle that gives you a sine value of 1.8 or a sine ratio of 1.8. And that, friends, is why this expression does not have an answer. So you can just say does not exist, or undefined, or impossible, or whatever. Yeah, does not exist. So the inverse cosine, same approach as the inverse sine. The only difference is in the range. So on the inverse cosine, the domain is absolutely the same, because it's still the same condition that there is no cosine value, cosine angle. There's no angle that gives you a cosine that's bigger than 1 or smaller than -1. So the domain is the same as the inverse sine function. The only difference is in the range, and the range of the inverse cosine function is from 0 to pi. Remember, the one for the inverse sine function was from -pi over 2 to pi over 2. This one is from 0 to pi. Excuse me. And this simply because of how the tan graph starts, how the cosine graph starts up here and then goes down. And I hope you can see that when I flip that, or when I rotate that, let me try to rotate it. When I rotate that and turn it into an inverse function, then it is starting exactly at 0, because this point here was at 0, right? I'll have my full graph starting at 0. So that's why its range is going to be from 0 to pi, and you have a full period at pi. So yeah, that's the domain and range of an inverse cosine function. The domain and range of an inverse tan function is just this and that. Same explanations as for the sine function. But what I want us to focus on the most is the sine and cosine. So you will get this, but it won't be as common as the other ones. Domain is negative infinity to infinity because of the shape of the graph, and the range, interestingly, is negative pi over 2 to pi over 2. So with this, we can look at some practice. The exact value of this composite function, the inverse sine of the cosine of pi. So you break this down starting with what's in the parentheses. In the parentheses, you have the cosine of pi. I know the cosine of pi is cosine of 180, which is equal to negative 1, right? That's a very big bracket. Negative 1. And now I'm trying to find the inverse sine of negative 1. I'm asking myself, which angle gives me a sine of negative 1? That's the question I'm asking myself. And we all know that angle is 270 degrees, which is 3 pi over 2, but it's negative because this is negative. Yeah. Sine of the tan inverse of 4/3. Okay, so you're asking yourself, what is the sine of the tan inverse of 4/3? You can do this without a calculator or with a calculator, your choice. But just I'm going to cover without a calculator because that's the one that's more problematic if you're restricted to not use a calculator. So when you're doing tan inverse, I'm going to start with tan inverse because it's what's in the bracket. This is going to equal to some x value, and this x value is an angle, right? This is an angle. Let me just put this degree just so you see it's an angle. So I'm asking myself, what angle gives me a tan of 4/3, right? And if this angle is x and it's over here, and tan is 4/3, I know tan is opposite over adjacent, right? So this opposite is 4, and the adjacent is 3. And in this triangle, if I use Pythagoras, and you guys can try this, I'll say 4 squared plus 3 squared equals c squared. 16 plus 3 is 25. Oh, sorry, 16 plus 9 is 25. And I'll find that the c is 5, right? So I have found that the c for this triangle is 5. I don't even need to find this angle. I don't even need to find the angle, but all I know is I am trying to find the sine of that very angle, right? Because the inverse tan of this angle, the inverse tan of 4/3 is equal to x degrees. So when I'm trying to find the sine of that inverse tan, I'll just find the sine of that same degree or that same angle. And according to this triangle, the sine of that angle is opposite over hypotenuse. So I can see that the opposite is 4 and the hypotenuse is 5. So the sine is just 0.8, right? So the sine of that angle is 0.8. So you can conclude that the sine of the tan inverse of 4/3 is 0.8. Now, I hope you can see how useful it is that early mathematicians who did not have calculators yet didn't have to struggle with these compositions, because if you know this process and if you know the meaning of each of the functions, then it's easy to get from one point to another. Oh, homework. Yeah, this is your homework, and we'll talk about it in class on Monday, and your test is on Tuesday. So just, yeah, get busy. Bye.